My name is Mohammad Tawheed and my register number is 24BDS1201, and the topic I've chosen for my DA-1 is OSI model versus TCP/IP model. I'll be going over why we use layered approach in networking, what is the OSI model and its 7 layers briefly, the TCP/IP model briefly, and then comparing both the OSI and the TCP model. Now, first, why we use layering. As we know, communication between two computers is very complex. It's not simple. It involves sending signals, ensuring reliable delivery, routing, formatting data, and running applications. Doing all that in one giant step, in one giant block, it would make networks complicated, impossible to standardize, and hard to troubleshoot. So networking follows a layered approach to reduce these disadvantages. Layering breaks the communication into smaller, manageable tasks, adds modularity, and ensures interoperability between vendors. And it also makes upgrading and debugging easy. In layering, each layer has a defined function. As we know, in communication, there's a sender, there's a carrier or a medium, and there's a receiver. So the sender side will also have layers, and the receiver side will also have layers. The sender layers on the sender side add functions, while the layers on the receiver side undo these functions. And then the same layers that are on the sender side will communicate with the same layer on the receiver side. Let's say I have a layer A on the sender side, so it will only communicate with the layer A that is on the receiver side. It will not go communicate with a different layer like layer B or so. This is called peer-to-peer communication. Now, what is the OSI model? OSI stands for Open Systems Interface. It is a standard that was made by the International Standards Organization (ISO) that covers all aspects of network communication. The purpose of OSI was to show how to facilitate communication between different open systems without requiring changes to the logic of the hardware and the software of the systems. It is not a protocol but a model for understanding and designing network architectures that are flexible, robust, and interoperable. OSI is a layered framework for the design of network systems that allows communicating between all types of computer systems. It has 7 layers that are separate but related. Each of these layers define a part of the process of communicating across a network. How was this model developed? The designers first broke down the process of transmitting data into its most fundamental and basic elements. They then identified which networking functions were similar or related and collected them all in discrete groups called layers. And each of these layers contain functions that are unique to them only. That means 2 layers will not have the same function. The OSI model has 7 layers. The lower layers deal with data transmission, while the upper layers support applications. For now, I'll go over the 7 layers briefly. The first layer and the lowest layer is the physical layer. It transmits raw bits through cables, fibers, or wires, or wirelessly. It handles signals synchronization, physical topology, and line configuration. The second layer is the data link layer. It ensures reliable node-to-node delivery. Its functions are framing, MAC addressing, error detection and error correction, flow control. And devices handled by the data link layer are switches and bridges. The third layer is the network layer. The network layer handles source to destination delivery across networks. Its role is to The third layer is the network layer, and it handles source to destination delivery across networks. Its other responsibilities also include logical addressing, routing, and forwarding packets, and the device under the department of the network layer is the router. The fourth layer is the transport layer. The transport layer provides process to process delivery, and its functions include port addressing, segmentation and reassembly, flow and error control. Protocols under the transport layer are TCP and UDP. TCP is reliable and UDP is faster but no guarantee. So I would use TCP but TCP is more useful when you're downloading a file from online from the internet, because you cannot tolerate missing data. The file would be incomplete, so you would use TCP more probably. And then UDP you would use, let's say you're watching a cricket match live, any sports match, or you're playing some game. A small packet loss is fine. If the connection is unreliable, it's okay, but it has to be fast. If it starts buffering a little bit, you will lose patience, so you would use UDP. Now the fifth layer is the session layer. The session layer manages communication sessions. It establishes sessions, maintains communication, controls who speaks when, and adds synchronization checkpoints. The sixth layer is the presentation layer. The presentation layer deals with the format of data. It translates data formats, handles encryption and decryption of data, and manages compression and decompression of data. And then the seventh layer is the application layer. This is the topmost layer and interacts directly with the users. It provides services like email, file transfer, web browsing, and DNS. The protocol for email is SMTP. For file transfer, it's FTP. And for web browsing, it's HTTP or HTTPS. This layer, the application layer, is where applications access the network. For easier understanding, you can think of sending a letter as networking. The application layer is you writing a letter. Then the presentation layer would be you making sure the language and the format are all correct and understandable to the receiver. Then the session layer would be you and the receiver agreeing to communicate. I will send you a letter, you will receive a letter from me. Yes. The transport layer is dividing the letter into pages. Like you cannot fit everything into one page, so it will be divided into multiple layers. So that's what the transport layer would be handling if sending a letter was to be understood as networking. Network layer would choose the best and the fastest delivery route. The data link layer would be you putting the letter in an envelope with the addresses written on it. And the physical layer can be the postman delivering the letter to the post office, and then from the post office another postman delivering it to the receiver. If I had to explain with an actual example, let's say you open YouTube. The application layer will create the HTTP request, and the transport layer will use TCP and divide the data and adds the ports. Then the internet layer will add the IP and decides the path to take across the internet, and the network access layer frames and then signals over the Wi-Fi/LAN. Now let's talk about TCP/IP. It's the real world internet model. Unlike OSI, which is theoretical, TCP/IP is actually implemented everywhere. It's used on the internet, it's used for mobile networks, it's used for Wi-Fi, it's used for servers, and it's used for cloud storage and cloud related services. It was originally made by ARPANET for military use, due to which it was made in such a way that it should work even if some parts of it fail, and should allow different vendors, and it was scalable worldwide. Unlike the OSI model, TCP/IP has 4 layers, while the OSI model has 7. The first layer is the application layer, similar to the OSI layer, but it combines the OSI's application layer, the presentation layer, and the session layer. So it handles application communication, data format, and encryption as well. The protocols under this layer are HTTP/HTTPS for web browsing, FTP for file transfer, SMTP, POP, IMAP for email related services, and then DNS that converts website names to IPs. Then the second layer is the transport layer, responsible for end-to-end delivery between applications, and is done using port numbers. Protocols under the transport layer are again TCP and UDP. Similar to how TCP and UDP work in OSI, here it's also the same. TCP is more reliable, ordered, and there's acknowledgement from the receiver, while UDP is fast, but there's no guarantee and there's no retransmission. It's not reliable, as I said earlier. TCP is used for accessing the internet, banking, or downloading files, while UDP can be used for streaming movies or playing games or calls. The third layer is the internet layer, also known as the routing layer. It provides logical addressing and routing and uses IPv4/IPv6. IPv4 uses 32-bit addresses, while IPv6 uses 128-bit addresses. So a few supporting protocols like the ICMP, ARP, IP, and DHCP. ICMP is used for error messages, ARP IP is used for MAC addressing, and DHCP assigns the IP. ARP converts IP to MAC inside the local network, and DNS converts website names to IP addresses. A small difference between DNS and ARP. Fourth layer is the network access layer. This is the lowest layer of the TCP/IP model. It combines the data link and the physical layer of the OSI model, and it's responsible for framing, MAC addressing, and accessing medium and sending bits as signals. Examples are the Ethernet, Wi-Fi, Fiber DSL. These all come under the network access layer. To make it easier to understand the TCP/IP model, I will again use the example of YouTube. When you open YouTube on a browser, the application layer will send the HTTP request, then a transport layer will segment the data using TCP, then the internet layer will decide the route using IPs, and then a network access layer will convert the data into frames, then into bits, and then it will receive it through the Wi-Fi signal. So finally, the key differences between the OSI model and the TCP/IP model are that OSI is purely theoretical, while the TCP/IP is more practical. It is actually implemented in real world situations. OSI has 7 layers that are the application. This is from highest to lowest. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and the physical layer. While the TCP/IP has only 4 layers that are the transport layer, the application layer, then the transport layer, the internet layer, and the network access layer. In real networking, we implement TCP/IP. In real world situations, we use TCP/IP. But concepts are explained using OSI because OSI model, it makes it easier to teach and explain networking related concepts. So I would like to end the video by summarizing what I've explained in the video. To summarize, layering simplifies communication. OSI explains the concept of layering with 7 layers. TCP/IP has 4 layers and is the real world implementation of the layered approach. Thank you.